Okay, these are the notes for 7.2. We are graphing rational functions. The equation of a rational function would be f of x equals, well, the parent function is 1 over x. The graph is a hyperbola, which consists of two symmetrical parts called branches, and the domain and range are all non-zero real numbers. So you notice in the picture on the right, it has asymptotes, which means the graph will approach it infinitely, but never actually touch it. So the graph actually never stops. It, like right here, would actually go up forever, but it's never going to cross this x equals 0. Okay, not up or down. And it's also going to keep going down here forever and ever and ever and get as close as possible, which can go infinitely. And then same thing with y equals 0 and y equals 0 here. So the only numbers in the range that don't work for the parent function is x equals 0. And the only number for, I'm sorry, did I say the range? The only number for the domain is x equals 0. And the only number for the range is y equals 0. Because the parent functions has those asymptotes. So any function of the form where you have the function equals some variable over x, and that variable cannot be 0, okay? It can be negative, that just reflects your graph. So remember, it reflects over the x-axis, so this one would actually come here and here. They'd still be kind of in opposite quadrants, but if they are in quadrant 2 and 4, that means you had a reflection, which meant a was negative. It still has asymptotes and the range and the function of 1 over x. So if we're going to actually do some transformations on this, we have the same format. When it's grouped with x, that moves our graph right or left. It's always the opposite of what it says. So instead of x being negative, like this would show, it would actually be a positive. So we draw the asymptotes, which in this case would be h. In this picture down below, I'm not showing the exact number, but okay, here it is at h. Here's that asymptote right there. Okay, this would be your y asymptote. Whatever that number is your y asymptote. Remember, that's what moves your graphs up and down, just like every function we have done this year. If it's grouped with x, it moves you left and right. You just do the opposite of whatever it says. If it's x plus something, you actually go left instead of right, okay? And then if there's a number tacked on to the end, that moves you up or down. And you do what it says. If it's positive, you move up. If it's negative, you move down. Okay, so those are your asymptotes. If your function, or if a is positive, you're going to be, if you consider that your x and y axis now, you're going to be in your first and third quadrant, okay? But now we're going to plot the points from there, where I recommend plugging points in, or plugging the equation you're given into your calculator and looking at its table. So that helps a little bit too. But let's go ahead and give some problems a try here. So I'm going to kind of write down, because I'm going to zoom in a little bit, see what this wants. A, it wants me to sketch it. B, all of these are B. Okay, so these are the transformations. Okay, and then C, it wants the equation of the vertical asymptote. D, it wants the horizontal asymptote. E, domain, and F, range. Okay, we got that. So given this equation up here at the top, this negative right here, so that means A is negative 4. The negative just means we have a reflection. So I'm going to write, the first thing it does is reflect. Okay, so that's easy. That's going to tell me, instead of being in this quadrant and this quadrant of wherever my asymptotes are, it's actually going to be in this one. So I'm going to have something over here, and I'm going to have something over here. Okay, so it reflects. This not being a 1, remember the parent function has a 1 on top. Well, it has something bigger than 1. So it's actually going to have a stretch with a factor of 4. or you can, actually let's shorten it. These lines aren't very big. I'm just going to put stretch of 4, okay? Grouped with x, so this is what moves us right and left. So it's an x minus 2, which means I'm going to go where x is positive, so that's to the right. So I'm going to go right 2. And then it has a plus 2 on the end, which moves it up and down. And it's positive, so I'm going to go up, because that's where y goes positive. So I'm going to go up 2. All right. Even just looking at the equation, we can write the vertical asymptote. Remember, the vertical asymptote, we use this number, except it's always the opposite. So it's plus, x being plus 2. So I know I have an asymptote right here. Okay, and that equation is x equals 2. The horizontal asymptote, I said I moved up 2. So instead of being the x-axis, it's going to move up 2. So I have y equals 2. Okay, so there's my asymptotes. So I know I'm going to have some graph in here, because it had that reflection. And our domain. Remember, the domain is all real numbers except where that asymptote is. So, so domain is all real numbers except for 2. But if we write that in interval notation, which is how we've been writing domain and range all year, we would write this as, well, it's going to come from negative infinity. It's going to approach 2 infinitely, but never touch it. So it gets a parentheses. It doesn't actually equal 2 ever. And I put this, which means union, from 2, which it doesn't touch it, but right on the other side of 2, it goes on to positive infinity. Okay, so there's my domain. Now the range is the same way. It starts down low forever. It's going to come up as it approaches this horizontal asymptote. So it's going to equal 2. But then after 2, it'll go up. Whoa, sorry about that. I just jumped some things here. Oops, wrong way. It's going to, it is not letting me write. That's why I'm on the arrow. To infinity, right there. Now remember, both of these in this case, both mean all real numbers except 2. So in the domain, except x equals 2, in the range, it's except y doesn't equal 2. Okay, but we want to finish and graph this, okay? Now, I know that my a was 4. Now, if I did not flip it, so if it wasn't negative, I would go from this intersection here, I would go right 1 and up 4. But it actually is flipped, so I'm going to go right 1 and down 4. I know that point. I also go left and up, so because you got to go the opposite quadrant. Those 2 points I can easily get just from looking at the equation, but that's an awful lot to be able to then figure out after that. So if you plug in numbers for x, so I always start a little t-chart over here. Okay, you can enter this equation into your graphing calculator. Just remember to put x minus 2 in parentheses. And then you can click on the table. Instead of pushing graph, if you push the second button and then graph, it'll give you a table. And then I just look at where it's starting to get close to the asymptotes and go from there. So I got like -3 and I get 2.8. -2, 3, -1, 3.3, repeating, 0, 4, 1, 6. 1, 6 is that point I already put on there. Because then at 2, x being 2 is my asymptote, so I know I can't get anything there. So your calculator actually will say error. Okay? And then you want the points after your asymptote, because remember, it's a hyperbola, so you have points on both sides. And if you don't want to use your graphing calculator, you do not have to. You know where your asymptote is. So if I know I have an asymptote at 2, I'm going to plug in 1 and see where my y is. I'm going to plug in 0, see where my y is, and just keep working my way left. and then do the same thing. I know I have an asymptote at 2, so I'm going to plug in 3, 4, 5, 6, okay, just to get some points. And so if we plot these points, remember the 0, 0 is right here, okay? Now that's not part of my graph, but that's where I'm starting at. So I go -3, and then I go up 2.8, -2, 3, -1, 3.3, and then 0, 4. So here are those points. Remember, it does not cross those asymptotes. So don't let it. Okay. And then I plot the ones on the other side. So I go right 3, down 2 is already the point I have. At 4, 0. At 5, I have 0.6 repeating. Whoa, my dot kind of went nuts there. And then at 6, I go up to 1. At 7, I'm at 1.2. And see, it just approaches that asymptote. So I'm going to go like that. And then there's my pretty graph. Okay? So you can draw your graph first if you'd like, by getting those points, seeing what doesn't work, and then filling out all the information on the transformation. Or you can fill out all the information based on the equation and go from there. So if we start number 2, sorry, I just decided to do, by doing the graph first, well, I can start with my points here. Okay, and so if I enter this in my calculator, I can see where the asymptote is. Well, and by the equation, I should know that it's at -3. So I know I'm going to have a -3. The calculator gives me an error. If I plug -3 in for x, I get a 0 in the denominator. That's why that's an error. You can't divide by a 0. So that's my asymptote when x is -3. So here, we can go ahead and draw that in. We know the horizontal asymptote is at y equaling -2. Okay, and then I go from there. So I want to plug in, I want to go farther to the left, so I'm going to go with -4. If you just plug it in to the equation, you get -4. If you're looking at the chart, it also gives you that. I encourage you to use your resources. You have them for a reason. It does save you time. And let's see, -7, and then -2.5. I don't know that we need to go that far, but I did. And then -2, if I plug that in, I'm going to get 0, -1, -1, 0, -1.3 repeating, and then 1, -1.5. And I'm going to plot these points. So my graph will go, if I go over to -7, down 2.5, 2.6, 3, 4. And so I had told you before, whatever A is, like if I go right from where my intersection is, if I go right 1, I go up that much. Since this isn't negative, it's going to go up. And then I do the opposite, which gives me this one right here. Okay, so those 2 points, the equation itself gives you, but we also got them by plugging in or using the chart. All right, so at -2, I'm at 0, -1, -1. Let's see, 0, -1.3. Okay, so here is my hyperbola. 1, and then 2. Okay, so I have my graph. I'm gonna, zoom out. Sorry, I'm having trouble moving it here. And using that graph, I want to fill out the transformations. Oops, let me show the equation too. Okay, so we know it has a stretch of 2 because that number on top is not 1. It's greater than 1, so that means it's a stretch. There is something grouped with x, so it moves left or right. Well, we moved it left 3. That -2 on the end is going to move us down 2. Okay. Vertical asymptote is that one going up and down, and it crosses the x-axis, so that is an x equals, and it's -3. The horizontal asymptote goes like along the horizon, so it's going this way right here. So that's a y equals, it crosses the y-axis at -2. So my domain is all real numbers except x being that -3 where the asymptote is. So if I write it in interval notation, it's going to go to -3, and then from -3 it'll go back up, okay? But notice no square brackets, because it is not going to actually equal -3, and that's what that U kind of puts in there. So this is all real numbers. You can say it either way. All real numbers except x cannot equal -3. And then, or you can say all real numbers except -3, whichever. And then the range are all the values of y. So it starts down, goes down forever. It's got an arrow going down. But then it comes up and it approaches that -2, never touches it. But then on the other side of -2, it then goes up to forever. So this is all real numbers except y cannot equal -2. All right. So that's the main information for the transformations of, my brain just went blank. The transformations for irrational functions. The questions in the practice might split it all up. It won't give you one problem wanting everything. It might just ask you, what's the vertical asymptote? Or does this stretch? Or that kind of thing. So do the practice on Big Ideas Math. It's the 7.2 practice.